In this video, we're going to continue our practice with trigonometry to find sides. So in this first problem, it says find the value of x. All right, so you're given angle 43. And I want you to notice whenever we're working with SOHCAHTOA, you're always coming from an acute angle. So let me write my favorite little phrase over here so I know which sides to divide. So the acute angle right here that we're given is 43. If I go across the triangle to the opposite side, this is opposite. Across the box is your hypotenuse. Next to my angle is my adjacent. Now, I don't want to use the hypotenuse because it doesn't have a number and it doesn't have an x. You're only working with the sides that you've got. And so in this case, that would be opposite and adjacent. So we know we've got to use tangent, which is the ratio of the opposite over the adjacent. So I'm going to set up tangent of my angle is equal to opposite over adjacent. So we have to solve for x, and just like we did in the previous video, it's being divided by 12, so we'll multiply both sides by 12. So 12 tangent 43 is equal to x. And then we'll take this to Desmos and find our answer. Okay, so I have, and I'm just going to check, make sure it didn't change, it's still in degrees, 11.2. All right, let's try this again. Let's see, we know that this guy is 11.2 because these are the same measures as the previous problem. We have 43 is the acute angle, 12 is the adjacent, 11.2 is the opposite. Why don't we use Pythagorean theorem? 12 squared plus 11.2 squared is equal to y squared. Let's see, that's 144 plus 125.44 is equal to y squared. We add these together. Let's see, 5 and 4 is 9, 2 and 4 is 6. 269.44 is equal to y squared. And when we take the square root, y is equal to the square root of that. So 269.44. Let's see, square root 269.44. Oops. How about 16.4? And that's done. All right, I'm going to show you a different way to do this one now. Instead of using Pythagorean theorem, what we could have done is, well, use a different trig ratio. So let me erase that 11.2, and let's see, I'm going to go ahead and label opposite, adjacent, and across the box is your hypotenuse. So the ratio that uses adjacent and hypotenuse would be cosine. Again, I don't want to use the guy that doesn't have a number or an x, so I'm not using opposite. I'm using the ratio of the adjacent over hypotenuse. And so this is going to give me cosine of 43. It's always the cosine of the angle is equal to adjacent over hypotenuse. So I would solve this by multiplying both sides by y and dividing by cosine 43. And I get my y is equal to 12 divided by cosine 43. Let's check out Desmos and make sure we have the same answer. So this is going to be 12 divided by cosine, open parentheses, 43. And again, we're getting 16.4. It's a little bit off from the previous answer just because we rounded the 269.44, but it's still pretty close. 16.4 would be my rounded answer, which is the same thing we got using Pythagorean theorem. Okay, a couple more examples. I label opposite. I'm not going to need the opposite just because I don't have a number or an x. But that helps me rule out, well, 14 has to be the adjacent because across the box is your hypotenuse. So I need the ratio with hypotenuse and adjacent. SOHCAHTOA. Hypotenuse and adjacent would be cosine. So this is cosine of the angle is equal to adjacent over hypotenuse. Solve for x by multiplying both sides by x and divide by cosine 55. And x is equal to 14 divided by cosine 55. 14, abbreviate COS, open parentheses, 55, and we have 24.4. All right, our next example, let's see, we have go across the triangle. This is opposite. Across the box is hypotenuse. I don't want the adjacent because it doesn't have a number or an x. So I'm looking for hypotenuse and opposite. And this time, it's going to be the ratio of my sine. So this is sine of my angle is equal to opposite over hypotenuse. Y is being divided by 9, so I need to multiply both sides by 9. And y is equal to 9 times sine of 27. 9 times sine, S-I-N, open parentheses, 27, 4.1. All right, one last problem. It says find the value of z. This time that's the angle. All right, so from this angle, go across, identify your opposite, go across the box. This is your hypotenuse. So we know we're working with sine because that's the ratio of the opposite over hypotenuse. So sine of the angle is equal to opposite over hypotenuse. In order to solve this one, we have to undo sine. So to undo sine, we have to take the inverse on both sides. Okay, the inverse is going to cancel the sine, and you're going to end up with z equals. So z is equal to the sine inverse of 5 over 14. Now let's take that to Desmos. Okay, so this is sine inverse. So I'm going to type in sine, and then I'm going to raise it to the -1, open parenthesis, and I believe that was 5 divided by 14. Okay, let me just make sure I have that correct ratio. Inverse sine of 5 over 14. Yep. My angle is 20.9 degrees. And we're going to practice this a little bit more in our next lesson. But this is 20.9 degrees. That's how you solve for an angle.